Now it's your turn to try your hands on these four problems and try to find the x-intercepts for these quadratic functions that are perfect square trinomials. And whenever you're ready, you can continue the video and we'll go over the solutions together. In part A, we have this function f of x, and we notice the first thing that we have a plus sign for the linear term, so that means we're trying to check whether it resembles the form of a plus b squared. And once we have this recognition, we want to identify what a and b are in this case. And the first term is x squared, so our a would just be x in order for the term to be equal to a squared. The second term, the last term, should be equal to b squared. So if we know 25 is equal to 5 squared, that means b equals 5. And once we identify a and b, we can go ahead and check whether 2ab is indeed equal to the middle term, whether it's equal to 10x or not. So if I have 2 times a, which is x, times b, which is 5, multiply this out, we can check if we have this whole thing, we indeed get 10x equals 10x. So the middle term is indeed 2ab. Now knowing that we're looking for a squared plus 2ab plus b squared, that can be written out to be a plus b squared. That's exactly what we're going to do. So f of x is equal to a plus b squared, with our a being x, b being 5, and we connected with plus sign because the middle term is positive over here. Now that we have this factored form, we can go ahead and set it to be equal to 0, and the only distinct factor we have is x plus 5 being 0, and x is equal to negative 5. Therefore, the x-intercept is negative 5, 0. Whenever you're ready, we can move on to part B. And in part B, we recognize that we have a minus sign over here. So we should expect to get a minus b squared as a final result if all three terms meet the a minus b squared form. And we say if we have a squared minus 2ab plus b squared, this whole thing can be factored out as a minus b squared. So if the first term we have is a squared, that means our a has to be equal to x. If the last term is b squared, being 36, that means our b has to be equal to 6. And now we want to check whether 2ab is equal to the middle part, the 12x. And therefore we have 2 times x times 6, and we want to check whether that's 12x. And if we multiply everything, we should get 12x is equal to 12x. It does check. And once we have this form, that confirms our idea that this whole thing can be written as a perfect square trinomial and factored out to be a perfect square. And g of x, therefore, is equal to x minus 6 squared. And once we have this form to set this whole expression equal to 0, we can let x minus 6 equal to 0, and x is equal to 6. Therefore, the x-intercept we have will be 6, 0 as a result. And moving on to part C, we want to start off doing exactly the same thing, identifying what our a and b is and check whether the middle term is equal to 2ab. And here we have a squared being 9x squared. And again, the way to find a is essentially square root both the coefficient part and the variable part. And square root of 9 is going to be 3. Square root of x squared is x. In b, we have 25, which again is 5 squared. So we have b equals 5 in this case. And once we have this, we check whether 2ab is equal to 30x. If we have 2 times a being 3x, b being 5, compare it to 30x. On the left, we have the constants being 2 times 3, which is 6. 6 times 5 is 30. So we do indeed have 30x on both sides. And therefore, we can rewrite the whole expression to be a plus b squared. Same thing as before, it's plus because it's plus here in front of the linear term, and we would therefore get 3x plus 5 squared all together. Now to find the x-intercept, we can go ahead and set this factor to be equal to 0 and 3x equals -5, therefore x equals -5/3. And our x-intercept here is going to be -5/3, 0. And lastly, for part D, we want to go through the whole process again. If the first term is 25x squared, it's equal to a squared. To find a, we square root of 25 to get 5, square root x squared to get x. To find b, we are square root the 4. So square root of 4 is 2, because 2 squared equals 4. And once we have this form, we go ahead and check 2ab, whether that's equal to 20x or not. And in this case, because we have a minus 20x in the middle, we should expect the final form to look like a minus b squared if it checks out. And here, 2 times a will be 5x, b will be 2. And we check whether that's 20x. If we multiply all the numbers together here, 2 times 5 is 10, 10 times 2 is 20. So 20x does check out. And therefore, j of x can be written as a minus b squared. Again, make sure your sign matches the middle term sign. And this becomes 5x minus 2 squared. To find the x-intercept, again, we use a zero product principle to make sure that the factors we have are going to be 0, being possibilities. The only distinct factor we have is 5x minus 2 equal to 0. So 5x equals 2 and x equals 2/5. And therefore, our x-intercept is going to be 2/5, 0. And that's how we go about solving these problems when we have a perfect square trinomial. And this is considered one of the special forms we can do. So in this case, whether you have leading coefficient equal to 1 or not doesn't matter as much anymore. The key to recognize this type of trinomial is to check or recognize the first term and last term happen to be perfect squares. And from there, we can go ahead and check whether the middle term happens to be equal to 2 times our expression a times expression b. This is always a nice trick to use when you recognize it.